Hello everyone, we're Group 10. My name is Nicholas Poplowski. This is Saif Al-Takriti, Mohammed Muhammad. We got James Dale over there, and we got Randall Cox right there. And today we're going to be talking to you about our senior design project, which is the puddle pump. So I'm going to pass it over to Mohammed.
So during the past few years, we have had a lot of experience of flooding and hurricanes. Such as in Harvey, a lot of people didn't have water nor power to use. Luckily, we have recovered pretty fast from that situation. Unlike some other countries around the world, such as in Puerto Rico, they're still suffering a power and water outage until today. Therefore, we have designed a system to fit their goals during that situation. Our main goal for that system is to collect and pressurize any surface water and make it available to use. We have picked for our system a 10 stages reverse osmosis system, filtration system, as a proof of concept. And the reason why we picked that filtration system is that to clean as much as possible of contaminants out of the water. Also, our system runs off 3 main power sources. 2 of these sources are completely off the grid. I'll pass it to Randall to explain some more.
To go a little more in depth in our design, our desire with this was to make it work anywhere. We didn't want you to be limited to where you might have a power source, a generator of any type, or just anything that you might need. To do that, we've included 3 different power sources. Our main source of power is a solar panel system. Well, we stuck with a solar panel connected to a charge controller and a battery. This allows you to run the system during the day when you have sunlight off the solar panel. It also charges the battery throughout the day and allows you to run off the battery at night. So the system ideally can run completely off just this one system. As 2 different backups we have in case you have other sources. We have an AC to DC converter that allows you to run the system if you do have a 120 volt outlet. And we have also designed a pedal power generation system that allows the system to run in the event that both other sources of power fail, such as the battery failings or the solar panel not having enough light. In any event, you'll be able to run the system and get water. I have a short video showing the pedal system working and starting to flow water through our system. As stated earlier, our main goal with this system was to collect surface water and then pressurize it for use. To do this, we found that it is most efficient to use 2 separate pumps. We wanted to be able to collect water and not have to be super close to it. So we were using a submersible pump connected to a hose that will bring water into our system, and that can be up to 30 meters away with about 5 foot of elevation change over that time. Once the water comes into our system, we store it in a reservoir. From the reservoir, we then pressurize the water with a second pump. Once the water is pressurized, we then feed it to our filter system. For our prototype, we have used this 10-stage reverse osmosis filter to get it all the way to drinkable. We chose this not only because we wanted to prove that we can get it all the way to drinkable, because that's the hardest to get it to, but also because this type of filtration is very restrictive and slows the flow down and slows everything else down. We wanted to prove that we could do this, so if we needed to if we didn't want to filter the water quite as much, we can have other filter options that restrict it much less and give us much higher flow rates and much more water to use for other applications other than drinking. I'm going to pass it on to James to explain a little more in depth about how the rest of the system works.
So to operate the system off of pedal power, you plug in the cord from the generator into the 12-volt receptacle and use the toggle switch on the left to decide which pump you want to operate. The pumps are split for the pedal power only to make it easier for the person who's pedaling to maintain the 12 volts needed to operate the system. If you want to use the AC system or solar system, you disconnect the generator and use the toggle switch on the right to choose which of those power systems you want to use. With either of those power systems, the system runs completely automated. So both pumps will turn on and off as needed, and there's built-in safety features to prevent the system from being damaged. The low pressure pump has a level switch in it that will shut the pump off automatically if the pump is not submerged adequately. This will keep that pump from running dry. The reservoir has two level switches. The high level switch will shut off the low pressure pump to prevent the reservoir from being overflowed. The low level switch will turn off the high pressure pump to prevent that pump from running dry. The high pressure pump also has a shut off at 60 psi that will prevent it from overpressuring the system. We have a video here of the high level switch operating the low pressure pump.
All right, so I'm going to talk about a little bit more on some of the stuff that we did for the project. We decided to run a finite element analysis on this system, and one of the first tests that we decided to run is on the complete system itself. We wanted to make sure that it would be able to work in every day-to-day use. So how we wanted to test this is we decided to take the total weight and double it, convert it into a force onto the bottom of the system. And as you can see here, we have around 2.7 KSI, which is in the allowable amount of stresses on the system. And then for the second part, we also wanted to check and make sure that our dirty water reservoir tank would be able to hold the amount of water that is in the system, which is around 15 gallons. So what we did here is we also doubled the pressure inside the reservoir and converted it into a force. And this is the max stress that we get, which is around 0.4 KSI, which is also in allowable range. For the final testing that we decided to do, we wanted to take it, our project into a somewhat remote area away from any electrical, anything like that. And we wanted to double check and make sure that we're able to run the system completely off-grid with both the pedal power and the solar power. We also tested and made sure that we were able to use the filtration system and take out any contaminants or bacteria that was in the water. So as you can see here, these are just a few of the tests that we ran: pH, alkalinity, and iron. You can see the before and after. The after being 6.5 on the pH and 0 parts per million on both the alkalinity and the iron. And a few other tests that we also ran were the bacteria test, lead test, and pesticides test. And after running these tests, we also concluded that the filtration system was able to take these things out of the water. I'll pass it on to Safe.
All right, so for flow rates, our system at the current filtration option that we're using, our system can provide clean drinkable water at a rate of 32 gallons per hour. That provides about clean drinkable water to approximately 1,700 people per day. Now, if we're looking at other unrestricted filter options, our system can run 132 clean usable water for general use per hour. We're looking at flushing about 1,900 toilets. We're also looking at taking 184 showers a day with other filter options. For the use, our system can run off the solar power all day. It can run off the battery for approximately 12 hours. We can also, with the pedal options, you can pedal for 2 minutes to get 1 gallon of clean drinkable water. You can pedal for 1 minute and get 15 gallons of dirty water into the water reservoir. The cost. Our system is currently at $1,700 to produce. The mass production cost per unit is $1,400, and the targeted retail price is at $1,550. Competitors. Those are some of the competitors that we're looking at. As you can see, none of the competitors have our options to run off of 3 power sources, which is, like I said, the solar, the electric, and the pedal power. At this filtration and this gallons per hour rate and this price, I would say our system is very competitive. For future design considerations, we're looking at multiple considerations, including a other filter options, bigger battery to run the system longer, longer hose for the submersible pump, and other options. In conclusion, we have accomplished our task. Our system, we have designed our system, we have built it. We have generated our initial testing. Since the initial test, we have made major improvement and modifications to the system and ran final testing. And we have found that we have achieved our goal. So with that, any questions? There's a video of the whole thing running from beginning to end as we receive questions.
So you fill it with a submersible pump that is not on the main unit?
No, yeah, it's up.
On the main unit.
It's connected to the back.
Okay, so there is a separate module that is connected to that you then put into a body of water. And
Yes,
then
we throw that in the water as, oh, I'm sorry. Okay, you throw that in the water, as probably saw in the video. Throw it in the water, switch the, one of the switches, it'll fill up the water tank inside. And as you can see,
so does the rate of pump affects the quality of water filtration?
No, sir. So this particular filter system is designed to work between it's like 40 and 70 psi. So as long as we get up to 40 psi,
Only then it will switch on.
it does. The full filter system does work properly, and with our pump, with our pressure pump working at 60 psi max, it's usually right up there at that range. Even with the bike system that gives a slightly lower psi, it's still in the 50s. It just doesn't quite max it out at every moment.
Well, the flow of the low pressure pump is a lot higher than the flow of the high pressure pump, so the 60 psi is maintained constantly.
So which one is the limiting factor for the rate of pump? Because you have 3 different options. So which one gives you the lowest pumping?
The bike system.
The
The bike system, because
How much?
because you have to do it one at a time. You bring the water in, you bring 15 gallons in to the system in 1 minute, and then you can get 1 gallon every 2 minutes, which is just a tad slower than the other systems. Our limiting factor, so half a gallon a minute would be 30 gallons an hour. It would be about 6 gallons less an hour than the rest of the system.
So what volume what rate are you saying you can filter it based off just the bicycle?
Just the bicycle,
Yeah.
you should be able to get close to 30
1 gallon
gallons.
per 2 minutes.
Yeah, 1 gallon, so half a gallon a minute.
Half a gallon a minute. Okay,
Yeah.
that seems reasonable. So what is your main target market?
It's slightly split between disaster relief and just off-grid use. We've thought our motivation a lot at the beginning was right after Harvey we started this, and especially now we're seeing things like Puerto Rico still not having available access to flowing cleaned water. Our goal is to just kind of provide water for places like that that are in still recovering from a disaster and need to get water flowing for them to do basic tasks with.
And also you can use it in any remote areas. So our main focus, our main goal is the disasters. And it also can be marketed to if you want to go, let's say, camping, or if you don't have an RV, you have a truck, you can take this, you can provide water to use.
Okay. So if somebody doesn't have a truck, I mean, how do you move that? I mean,
This was made for you to carry it in a truck or in
Or on a trailer.
in a large amount, you know.
I guess what I'm getting at is, what is the motivation? I mean, I can see different ways to do this. Like you have this assembled as, I mean, that's just the nature of the project, that you want a single object at hand. But when I see something like this, I'm wondering the utility of keeping it all in one self-enclosed package. So for example, you know, everything is your solar panel there. It is outfitted, completely dedicated to water purification now. But what if I want to use that power to power a refrigerator? What if I want to use that to power my cell phone?
You can use it to power your cell phone as it's set up right now. It has 2 USB ports.
Okay.
Other than that,
It has the USB ports on the charge controller.
Okay. Just you might want to explore options of. I mean, I understand that probably the requirements of the project made you steer you toward like the big self-enclosed, you know, single object. But when I see something like that, I'm thinking it might be better to make it as a kit or something like that. You might sell it as a kit without the frame even. Just, you know, and then they can use whatever tubs they have lying around or something like that.
So that was one concern. Like you see, our competitors didn't have any storage to store or collect the dirty water. For ours, we're making it a lot easier to carry the system, get your dirty water from the water source, and then bring it back to, let's say, your house or wherever you're going, and then filter it then. You don't have to carry 15 gallons of dirty water back and forth to where your system is stored.
To your other point about you being able to utilize it for other uses, anything that has like a car charger adapter on it can be plugged into that and run off of the solar or the AC.
How often do you have to change the cartridge?
Filtration cartridge? It depends on the use. On a normal use, it takes a long time, but if you heavily, between 3 to 4 months, you have to change the filter cartridge.
Because if you look at these, this kind of natural disaster, there's a lot of influx of contamination that comes in from all the sources.
Exactly.
So you need to have some kind of backup for the filtration system.
Right. So actually, our submersible pump, it kind of have a mesh in the bottom. It's not a mesh; it's like a built-in, so it doesn't take large particles in. And also in the tank, while the other pump is pumping the water into the filter, there's another mesh that filters inside.
Large particles
Over here.
So
There's a small mesh that takes as much as possible of particles, you know, to prevent it from going into the filter. So that also helps and gives a longer life to the cartridge.
So what is
to
the
replace
mesh
it.
size?
It's about 3/4 inch. That's the. It's the
That's
size
the
of
diameter of
the
the-
actual
that's the
hose.
Yeah, but the strainer
Straining
size.
size.
It's like 1 millimeter or
We
1
picked the
millimeter.
smallest thing we
It's
have.
you
about a
mean the-
millimeter. It's about a millimeter.
Yeah.
That's
Less,
to
maybe
basically
less.
do any large particulate that would mess up either pump or clog up the filter hoses, which are smaller.
Any other questions?
Where do you guys go from here? Like, what do you do with it?
So what I thought about with this actual system is it would be almost good as a disaster preparation, to where you can have it set up at your house in case you lose water or in case the utility pumps get flooded and you lose water or groundwater or the water becomes contaminated. You would have this set up already that can keep your house functioning.
I want you to think about, not so much with this, next steps in a global perspective. You don't have to answer my question now. I will get with Andres, but think about it in a global perspective. And I say that because you already thought about, Puerto Rico, but you also, I come from the Philippines, and oftentimes we run into this issue. So think about that. I want you to think about that, and I'll get with you.
Okay. Thank you.
Any other questions?
And I asked this to the last water pump project I saw. Have you taken this down to Buffalo Bayou and drank the water out of Buffalo Bayou from this thing?
Okay, we have not taken it out to the Buffalo Bayou. We have taken it out to the park.
Yeah, Arthur's
The Arthur's
River
River.
on
Okay.
But to prove, I'll go ahead and drink it.
That's still the water in it from our last test.
That is
Yes,
brave.
Buffalo Body would be really brave, though.
Make sure
You
you
guys are welcome to visit him in the around 4 p.m.
I'll take it there and you guys can see me.
We'll be here at the Expo all day. Come and check on them.
Come on, what you have to do to pass this class?
If you live to see tomorrow, I'll give you a day.
We'll be in touch.
I'll see you tomorrow.
I really love the motivational piece of it.
Yes. Okay. And what about fouling the tanks and lines?
That was also for future considerations. I mean, with the price that with the money that we had, we weren't able to really get anything that's able to withstand those types of conditions. So that is a future consideration that we
So at the end, I would like to thank everybody here.
Thank
I
you.
would like to thank our group for the countless effort, the availability, and the effort that was and the time that was spent in this project.
And a big thank to the professor too.
Professor Garcia for always being there, always motivating us.
Try to make me visit him in the office.
As you can see, Dr. Garcia has always been available, always been helpful.
To get some more.
Thank you.